In this video, I want to address some word problems involving systems of linear equations. Okay, so here we have several different types of word problems, and the idea with these is we're trying to think in terms of linear equations. These are usually the best ways to solve word problems like these. So let's just go through several of them and see if we can make any progress. So here's a pretty simple one to start with. It says the sum of two numbers is 42. One number is 2 times as large as the other. What are the numbers? Okay, so the sum of two numbers is 42. One number is 2 times as large as the others. Okay. All right, so if we know that the sum of two numbers, I'm going to say that these two numbers here, we're going to call them x and y. Real creative, right? So we know the sum of these two numbers, x plus y, is equal to 42. We also know that one number, in this case we're going to say x, is 2 times as large as the other. So we know that x is twice as big as y. Okay? So we have now these two equations, and we have two variables. So let's see if we can actually figure out these two numbers from this information we have. X plus y equals 42 and x equals 2y. Okay, so this is a perfect example of when we want to use substitution. So let's go ahead and take x equals 2y and substitute it in here in this first equation. This is going to give us 2y plus y is equal to 42. Okay, well, 2y plus y, that gives us 3y. Okay, and this is equal to 42. So what we can do is we can go ahead and divide both sides of the equation by 3. And we're going to get that y is equal to 42 over 3, or 14. So one of the numbers, y, we say is equal to 14. Okay? And then we also know that we can take this y equals 14 and substitute it in right here. So that's going to give us x is equal to 2 times 14, which is 28. So we know that x is equal to 28. So our two numbers are 14 and 28. Okay? These are our two numbers. And we can double check the information here. We know their sum has to be 42. So 14 plus 28, that is 42. And 28 is actually twice as big as 14. So we know it satisfies both of the conditions of the word problem. So 14 and 28 are our two numbers. Okay, here it says, at a hockey game, a vendor sold a combined total of 167 sodas and hot dogs. The number of hot dogs sold was 55 less than the number of sodas sold. Find the number of sodas sold and the number of hot dogs sold. Okay, so we know that we have both hot dogs, which we're going to say is H, and sodas, which is S. Okay, so we know that if they have a combined total of 167 for each of these, we could have S plus H is equal to 167. It also says that the number of hot dogs was 55 less. Okay, so the number of hot dogs, H, okay, is equal to 55 less than the number of sodas. So we have sodas minus 55 because we're taking away 55 from the number of sodas. Okay, so now let's go ahead and do some substitution in order to solve this. So what we can do is we can take this value for H, S minus 55, and we can plug it in right here. So this is going to become S plus S minus 55 is equal to 167. Okay, so if we combine like terms, we're going to have S plus S, which is 2S, minus 55 is equal to 167. Okay, now if we go ahead and add 55 to both sides here, we'll get 2S is equal to 222. And if we divide both sides by 2, we're going to get S is equal to 111. So we know the number of sodas is 111. And we can take this S value here and we can plug it right in here. Okay? So we have H is equal to 111 minus 55, which is going to give us 56. So H is equal to 56. So we know that sodas, they sold 111, and hot dogs, they sold 56. Okay, here it says a party rental company has chairs and tables for rent. The total cost to rent 2 chairs and 5 tables is $43, and the total cost to rent 8 chairs and 3 tables is $36. What is the cost to rent each chair and each table? Okay, so we know that we have 2 variables again. We have chairs, which we'll say is C, and we have tables, which we'll say is T. The total cost to rent 2 chairs and 5 tables is $43. So we could write that as 2 times C plus 5 times T is equal to 43. And then it says the total cost to rent 8 chairs and 3 tables is $36. So we could say 8C plus 3T is equal to 36. Okay, so now let's see what we can do here. So now we have 2C plus 5T equals 43, and 8C plus 3T equals 36. And now what we can do is we can try to solve this by a number of methods, but I'm thinking probably multiplication and then addition or subtraction is probably the way we want to go here. So if we were to multiply this top equation here by -4, okay, this system would become -8C minus 20T. Okay, so then we have minus or equals -172. Okay, so a -8C minus 20T equals -172. And then we have 8C plus 3T equals 36. So if we go ahead and add these two together, we'll get -8C plus 8C, that's 0. -20T plus 3T, that's -17T. And then we have -172 plus 36. That's going to give us -136. Okay, so we have -17T equals -136. So we can go ahead and divide both sides by -17. And that'll ultimately give us that T is equal to 8. Okay, so the cost of a table should be $8. But now since we have T is equal to 8, we can plug this back into either of our equations. I like the second one. So we have 8C plus 3 times 8 is equal to 36. That gives us 8C plus 24 is equal to 36. And we can take 24 away from both sides. Okay. And that's going to give us that 8C is equal to 12. If we divide both sides by 8, we're going to get that C is equal to 1.5. So the cost of a chair is $1.50, and the cost of a table is going to be $8. Okay. Now let's look at this one. It says a fruit company delivers its fruit in 2 types of boxes, large and small. A delivery of 6 large boxes and 2 small boxes has a total weight of 118 kilograms. Okay, and it says a delivery of 3 large boxes and 5 small boxes has a total weight of 112 kilograms. How much does each type of box weigh? Okay, so we have large boxes, which we'll say is L, and we have small boxes, which we'll say is S. Okay, so 6 large boxes and 2 small boxes, all right, that has a total of 118. So we have 6L plus 2S is equal to 118. And we also have that 3L, 3 large boxes, and 5S is equal to 112. Okay, so let's go ahead and see which direction we want to go here. Well, if we multiplied the second equation by -2, that would allow us to eliminate the L variable here. So let's go ahead and do that. So if we multiply the second equation by -2, we'll get 6L plus 2S is equal to 118. And now we'll have -6L minus, should be 10S, and this is going to be equal to -224. Okay, so let's go ahead and add these together. If we add them together, we're going to get these cancel. So now we'll have 2S minus 10S. That's going to give us minus 8S. And then we have 118 minus 224. That gives us -106. Now we can divide both sides by -8. And we're going to get that S is equal to 13.25. Okay, and you may use a calculator for these if you need to. So if we do 106 divided by 8, we get 13.25. Okay, so that means that a small box weighs 13.25 kilograms. Okay, and then now what we can do is we can go ahead and plug this back in. So I like the top one. So let's do 6L plus 2 times 13.25 is equal to 118. So this is going to simplify to 6L plus 26.5 is equal to 118. So now we can take away 26.5, and we'll have that 6L is equal to, let's see, is equal to 91.5. Now we can divide both sides by 6, and we get that L is equal to, so 91.5 divided by 6 gives us 15.25. Okay, so small is 13.25 kilograms, and large is equal to 15.25 kilograms. It's not much of a difference here, but sometimes it happens that way. So there we go. That would be your answer for this particular situation. Okay, let's look at one more. Here we have Frank will rent a car for the weekend. It says that he can choose one of 2 plans. The first plan has an initial fee of $40 and costs an additional 40 cents per mile driven. And the second plan has no initial fee, but costs 90 cents per mile. Okay, so what we're looking for here is we're looking to find out for what amount of driving do these 2 plans cost the same, and what is the initial cost when the 2 plans are the same. Okay, well, let's make an equation for the first one. So the first plan has an initial fee, so we'll say the total cost, C, is equal to 40 plus, let's say, $0.4 or 40 cents per mile driven. Okay? All right, so the cost of the first plan is equal to 40 initial dollars plus 0.4 of a dollar or 40 cents, 0.4 per mile driven, which we'll say is our variable m here, okay? And our second, so this is cost one. Cost two is we have the second plan has no initial fee, so we'll have this is equal to 0 plus 90 cents per mile driven, okay? So if you think about this, the thought here would be, let's think about this logically for a second, right? This first plan has an initial fee of $40. So if you pay some money up front, every additional mile that you drive is 40 cents per mile. So we know there's an initial large fee, but as we go off into an infinite number of miles driven, obviously it'll be less than infinity, but as we go off to an infinite number of miles driven, this first plan is actually going to be quite a bit cheaper because you have a much smaller growth rate, right? Your cost is going to go up at a much slower rate because it's been multiplying our cost times the number of miles we drive here, right? It's a much smaller number than 0.9. But in this one, we have no initial fee, but we're going to have a much higher rate that we're paying as we go. So if we want to think about this logically, if you're going to drive a pretty short distance, it's probably a good idea to choose the second plan because there's no initial fee associated with it. So if you're going to drive a couple miles down the street, you wouldn't want to pay that $40 fee. But maybe you wanted to drive from New York to Los Angeles, probably the first plan is going to be the way to go. But let's figure out exactly when we switch from plan 2 being the most cost effective to plan 1 being the most cost effective, okay? So what we would do is let's actually just set C1, cost 1, equal to cost 2, because that's what we're trying to do. We're trying to find out when C1 is equal to C2. So this is going to give us 40 plus 0.4 m is equal to 0 plus 0.9, or we just have 0.9 m. Okay, and now what we're going to do is we're going to solve for m. All right, so let's go ahead and take 0.4 m away from both sides, and that's going to give us 0.5 m is equal to 40. And if we divide both sides by 0.5, okay, we're going to get m is equal to 80. Okay, so at 80 miles, they cost the same. Okay, so what this is really saying is, if you're going to drive less than 80 miles, plan 2 is the way to go. All right? Plan 2 is the way to go if you're going to drive less. Okay? And if you're going to drive more than 80 miles, plan 2 is the way to go. Okay? So 80 miles and they cost the same. 80, if you're going to do more than 80, you want to go with plan 1. If you're going to do less than 80, you're going to go with plan 2. Okay? But it also wants to know what is the cost when the two plans cost the same. Well, the nice thing is now we know that if we plug in 80m, we're going to get that C1 is equal to C2. So we can just pick our favorite of these two equations. I like C2 because it's just 0.9m. So we have C2 is equal to 80 times 0.9. And that's going to give us $72. So $72 is what they are when they cost the same, and 80 miles is when they cost the same. Okay? So there's a good introduction to a few word problems. These are all quite a bit different, but they have a lot of similarities. So if you run into any trouble with these, you can always shoot me an email and ask for help, and I'm glad to see if I can help you in any way, shape, or form. Have a good one.